Hi, Bertha. Let's go through a couple of these questions here. Oops. Let's see if I can get back to that one. Okay. So we have this first example is negative 10x. Oops. Hold on. I'm going to copy it and then I'll show you the screen. 10x plus 2 equals negative 3. All right. So the first thing we need to do here is isolate this term, right? So in order to do that, we need to subtract 2 from both sides. These cancel. We get negative 10x equals, with negative 3 minus 2 is negative 5. So now we need to isolate that x, right, the variable, to solve. So then we divide both sides by negative 10. That cancels, so we get x equals negative 5 over 10. But that's not, or excuse me, positive, because we have a negative here and a negative. But that's not reduced enough, right? 5/10 is not reduced. Remember, if we divide top and bottom by 5, we get 1 over 2. So x equals 1/2. All right, and we can check that by plugging it back in. So we have negative 10 times 1/2 plus 2 equals question mark, right? Because we don't know yet if they're equal. So then negative 10 times 1/2 is negative 5 plus 2, question mark, negative 3, and negative 5 plus 2 is negative 3. So that means that this is the correct answer. All right, that's the first one. Let's see what the next one is. All right, this one's more of a word problem. So let's kind of shrink this down so we can see both. All right, so we have, you may remember that the formula to convert between Fahrenheit and Celsius is F equals, so this is the degrees in Fahrenheit, equals 9/5 C, which is the degrees in Celsius, plus 32. Where F is degrees in Fahrenheit and C is degrees in Celsius. It says, suppose that the equivalent temperature in Fahrenheit is exactly only 4 degrees more than the temperature in Celsius. Find the temperature in Celsius. So what they're saying, that wording means there's some Celsius and corresponding Fahrenheit where the degree in Fahrenheit is exactly 4 degrees more than the temperature in Celsius. So that means that F equals C plus 4, right? So now we're given a second equation. So we can plug this in for there and solve for Celsius, and then that will also tell us the Fahrenheit. So it's asking us find the temperature in Celsius. So now what we're going to do is rewrite this problem in terms of C or Celsius. So we have C plus 4 equals 9/5 C plus 32. And we need to solve for C. So we need to get all the C terms on one side of the equal sign and then all the all the numeric terms on the other side. So let's start with, let's go ahead and subtract 1C or C from both sides. The reason I'm doing that is because it's not necessary. You could start anyway. The reason I like to do that is because I know that 9/5 is bigger than C, or excuse me, 9/5 is bigger than 1. So I know if I have 9/5 minus 1, it's going to be a positive number. And I just prefer to work with positive numbers, but not at all necessary. All right, so this C is going to cancel. So now I have 4 equals 9/5 C minus C plus 32. So I need to combine these two terms, right? So 9/5 minus 1. Remember, if we just take this over on a little aside over here, 9/5 minus 1 is the same thing as 9/5 minus 5/5, right? Which equals 4/5. Okay, so we know now that we have 4 equals 4/5 C plus 32. All right, you're with me so far? All right, now we're going to just take this up here and we're going to keep working. So what we need to do then is get this term, the C term by itself. So we're going to subtract 32 from both sides, right? So 4 minus 32 gives us negative 28. So we have negative 28 equals 4/5 C, because these cancel, right? So now whenever you want to cancel a fraction out, you need to multiply by the reciprocal, because any number times its reciprocal equals 1, right? Because 4/5 times 5/4 equals 1. And that's what you want to have, 1c, right? So then we need to multiply this side by 5/4. All right, so these cancel. So we have c on this side. And when we have 5 times 4, remember that's the same thing, or excuse me, 5/4 times this, that's the same thing as saying negative 28 over 1. We can simplify this, right, by dividing by 4. So we have 35 degrees. So the answer should be 35 degrees Celsius. So now we can double check that. Let's go ahead and convert that to Fahrenheit. So let's say we have let's say we had this equals 9/5 C plus 32. And we said C equals, what did we say? 35. So let's plug that in there and see what we get. All right, so F equals 9/5 times 35 plus 32. And 9 divided by 5 times 35, oops, gives us 63. So this equals 63. Uh-oh. Hold on, let me just double check something real quick. So make sure I didn't miss the right subtract. Oh, minus 32 equals net. Oh, you know what? Hold on. I just realized where I made a mistake. Okay, hold on. This is negative. That's right, negative 35, right? Sorry about that, because there was a negative here. That was a mistake. Please be careful with your negatives. I'm sorry about that. All right, so let's go back. This is negative, negative. That's where my mistake was. Okay, so we have negative 63 plus 32. So negative 63 plus 32 equals negative 31. So we found that the Fahrenheit and the Celsius, and look, the Celsius is 4 more than the Fahrenheit, right? Or excuse me, the Fahrenheit is 4 more than the Celsius, which is what we said over here. The wording says, suppose that the equivalent temperature in Fahrenheit is exactly 4 degrees more than the temperature in Celsius, which is what we got here. So that is the correct answer. All right, let's see what else we've got down here. All right, let's see. We have, find the length of a rectangle given that the perimeter is 180 feet and the length is 5 times the width. So we have a rectangle, right? Rectangle. And it's the perimeter. We're given, I'm just going to write down what we know. The perimeter is 180 feet and the length equals 5 times the width. Now, one thing I want to show you really quick, I just use that lowercase cursive L. That's really common for L just because it can, that way you're not getting confused with 1. All right, so we know you have some width and then your length is 5W, right, from over here. And we know that the full perimeter equals 180. So recall that the formula for perimeter is 2 times the length plus 2 times the width. We're given this, and we're given this in terms of W, okay? So let's plug in our knowns from up here into this formula. So we have 180 equals 2 times 5W plus 2W, right? And what are we looking for again? We are looking for the length, right? Which makes sense. So first we need to find the width, and then we'll know the length. So let's go ahead and start solving and simplifying. We have 2 times 5W is 10W plus 2W. So then we have 180 equals 12W. So then we need to divide both sides by 12. Those cancel. And 180 divided by 12 gives us 15. So we know the width is 15. That means that the length is 75. Right? Because we were given this, 5W. The length equals 5W. So when we multiply 15 by 5, we get 75. And we can double check it then, right? So if we add up 15 plus 75 plus 75, we get 180, which is our perimeter. So we know that we got the right answer. So the answer would be length is 75. That's it. You need to be able to check it too. So you can't just get to the bottom, get to the answer and go, oh, Okay, because look, you had 36 here for the length. So if the length was 36, if you divide 36 by 5, you don't even get a whole number. So right there, there's something off. So always go back and check your number in the original formula or equation given to make sure you got the right answer. All right, let's see what else we got here. All right, so we've got on Saturday morning, it took, actually, I'm going to clear this out just so we've got a clean slate. All right, on Saturday morning, it took Jennifer 3.6 hours to drive to her mother's house for the weekend. On Sunday evening, due to heavy traffic, it took Jennifer 4 hours to return home. Her speed was 5 miles per hour slower on Sunday than Saturday. What was her speed on Sunday? Interesting. So we're looking at miles per hour. So what are we looking for? We're looking for her speed on Sunday. So we don't know how far it is. So, okay, so the key here is that we need to remember that distance equals rate times time, right? And we know that the distance on, what are these days? Saturday and Sunday? Saturday and, oh, Saturday, Sunday. So we know that the distance was the same, right? She didn't change her distance. So we have the distance from Saturday morning and the distance to Sunday morning or Sunday evening are the same. It's just that the rate and the time changed. So if we know, let's say we have, I'm going to write rate with a little s just for now. And then I can't even use an s because it's Saturday and Sunday. So let's use rate 1 and rate 2, just to let me show you what it looks like. We know that rate 2 equals rate 1 minus, so let's do this. We're going to let r equal the rate, the rate or speed on Saturday. And we're going to say s equals the rate or speed Sunday. That way it's a little easier to follow. So we know that s equals r, what did they say, minus, it was 5 miles per hour, right? So if we know that those two things were equal, the distance on Saturday was equal to the distance on Sunday. So let's say we would set these equal to each other, right? So we have ST equals RT. Actually, and let me do this again. So we had the time for Saturday. We're going to write time Saturday. And then we're going to have, I don't know, we'll just say H equals the time on Sunday, right? Which we were given that this is 3.6 and this is 4. Okay, does that make sense? I'm just giving these just so that it's really clear. So when we set up our formula or our equation, we know that the distance from Saturday equals Sunday. So these two things need to equal each other. So we have RT equals SH, right? So R is just R, and then the T is 3.6 equals S was given as R minus 5. I'm running out of room over here. I'm going to have to clean this up a little bit. Times 4, because that's RT and RT, right? But for the different days. If that doesn't make sense, let me know and I'll break that one down a little bit more. I just need to erase some of these. This one I think was just hard to set up. This one's, once you get it all set up, it's not bad, but I just needed a little bit of room over here. So I'm going to rewrite it a little bit cleaner. So we have 3.6 times R equals 4 times R minus 5. Okay, so again, from distance, here's our rate times time for Saturday. So this is Saturday, and this is Sunday. Because we know that the speed was 5 miles per hour slower on Sunday, and this was our time was a little bit more increased. Okay. So now once we solve this, we need to distribute over here, right? We need to simplify first. So we have 3.6R equals 4R minus 20. So in order to clear these out, we got to add 20 to both. Well, no. I'm sorry. That's not the right thing. We need to subtract 4R from both sides, right? So this is going to clear out. So we have 3.6 minus 4, which gives us negative 0.4. R equals negative 20, right? Are you with me so far on this? All right, so then